Hey friends, welcome to the part 9. We are looking at real questions on DP 203 Azure Data Engineering. This is the advanced certification. So you can click the join button or the link in the description to become a Cloud Ninja member, not Cloud Kernel. This series or this playlist is not available for Cloud Kernel members, only for Cloud Ninja members. Okay. By the way, this is the YouTube handle. You can look out for 650 plus videos on AWS, Azure Cloud, Google Cloud, and Snowflake certifications. If you have not yet subscribed, please do so. This will help you stay tuned to the latest certification content. This channel is totally dedicated to help you clear cloud certifications. We are no frills channel. You will not see pretty ladies on this channel. You will not see pretty faces. You will not see interviews. You will not see podcasts where we call pretty looking guests. Nothing of that sort happens here. It's pure content to help you clear certification. Okay. Let us look at this question. I hope you have already visited the previous parts. If not, then please do so. Okay, but there is no sequence to be followed in these parts. You can feel free to start with this question as well. You are designing a partition strategy for a fact table. So you have a big fact table. You are deciding how to partition this. This is about Synapse. Many questions will be on Synapse analytics. You have a table with following specifications. It has 20,000 products and it is using a hash partition. It contains 2.4 billion records. Massive, man. Just for 2 years, it has these many records. That means the company is very profitable, man, because it is making that kind of sales on these 20,000 products. Which number of partition ranges provides optimal compression? So the formula to be used here is we have 2.4 billion. You got to divide it by 60 million. That will give you 40. So this would be our answer. Let us look at this next question. You are creating dimensions, and this is again a Synapse question. You have this syntax. You are creating this dim product table. So what? So this is SCD, but which form of SCD? That is a question. What is SCD? SCD is slowly changing dimension. If you have customer tables, product tables, or employees tables, and if it changes over time, that means a customer changes their address from one place to other over time, then that is also an example of SCD. These are the different types: type 1, type 2, type 3. See, like I always talk about the thumb rule, if it is type 2, there will be three fields: surrogate key. Do we have a surrogate key and or identity? Yes, we have this. Do we have a start date? We have a cell start date. Do we have an end date? We have a cell end date. Now many people in some other websites, they have written that, hey, you know what, these start date and end date are just columns. They are not linked with purpose. These are same. These are for product. The product can be sold from this year to that year. Now a new product comes and it is sold from this year to that year. Okay, so this is a slowly changing dimension type 2. You can read this section here, this one. Pause this video and please read it if you want to understand the concept. It will maintain the full history. Full history means if a guy stayed in New Jersey, he moved to New York, say it will say, okay, this guy from this date to this date he stayed in New Jersey. From this date to this date he is staying in New York. Now there will be two records. So how will the record become unique? You have to add what you have to add. You have to add surrogate key so that it is auto-generated number and both records will become unique. Simple. So in this context, what is product key? We already saw product key is a surrogate key. It is talking about identity. It is not a business column because business column is derived from business entity and it is different to the surrogate key. So these will be our answers. Let us look at this next question here. Again, a Synapse analytics question, and this time it is not a dimension, it is a fact table. The table is called fact purchase, and it has these columns. Fact purchase will have 1 million rows of data added daily and will contain 3 years of data. That is massive, right? 1 million daily means 30 million per month. 12 3 the 36, that is 360 million per year. 360 into 3, almost 1000 million billion records. So transaction queries similar to the following query will be executed daily. Let us look at the query. This is the query. Select blah blah blah. Now the question is, which table distribution will minimize query times? Minimize query times. Now nobody uses replicated with this kind of high volumes, because replicated means each compute uh, cluster will have the full volume of data. Data will be duplicated. Okay. So doing this with such larger volumes will be very difficult. If you want to minimize data movement during querying, then we use replicated. Here the question is saying minimize query times, not data movement. Okay. Now hash distributed. In hash distribution, data is distributed across multiple compute nodes. Okay, and it is a very good data distribution option. It will help you with efficient query execution. That is what we want. The question is, hash distributed on what? On purchase key, on purchase key, or date key? Which one? Is purchase key or date key? So date key would be wrong in this context. Why? Because see, on certain dates, suppose transactions are not there, then suppose there are transactions only for 4 dates, so you have 4 partitions, 4 compute nodes, 4 partitions, or whatever, for distribution, and the entire data will be concentrated. You should have such stuff being used for table distribution, which can distribute the data evenly across different compute nodes. That should be your distribution strategy. If you do it on purchase key, then it would be evenly distributing the data. For that reason, this would be the answer. So in round robin, what happens is each row is assigned to next compute in a cyclic manner. Okay, so it's like there are 4 computes, 1 2 3 4 4. Okay, a new record comes, one takes it up. Okay, then a new record comes, one says, hey, let 2 take it. Then a new record comes, 1 and 2 say, hey, let 3 take it. Then again a new record comes, 1 2 and 3 say, hey, let 4 take it. So that communist approach, everybody should have uh, same amount of thing, irrespective of the hard work you are doing. You may be a very hard working guy, you may have worked 15 hours, other guy worked 4 hours, but when the fruit is reaped, everybody will get equal. That is communism for you. So this would be our answer. Okay, if you have not yet subscribed, this is your opportunity to subscribe and stay tuned to the latest certification content. This channel is dedicated to help you with cloud certifications. Which cloud, boss? Which cloud certifications? Various certifications on AWS cloud, various certifications on Azure and Google cloud. Plus we have Snowflake certification with cloud. The Snowflake database is becoming very popular. So we have Snow Pro and other certifications on Snowflake also. So by the way, parts 6, 7 and 8, they were uploaded for Cloud Ninja members. If you are not a Ninja member, please click the link in the description. Become a Cloud Ninja member, not Cloud Kernel. For Cloud Kernel, you will not get this certification access. Only for Cloud Ninja membership, you will get this content access. So stay tuned, stay focused, focus on the concepts. This is the YouTube handle of this channel. There are 650 plus videos on purely certifications. So focus on the concepts and try to understand how we are decoding the right answer.